Okay, thank you everybody for joining. I think we've got most of our attendees hopefully logged in. Again, hello and welcome to our webinar. Our topic today is wood structural panels and air barrier systems. My name is Bob Cusick. I am the Eastern Region Manager for APA, the Engineered Wood Association's Field Service Division, and I will serve as moderator for this session. As I mentioned earlier, handouts of the slides can be found in the control panel on your screen. To ensure that everyone can hear the webinar clearly, we have muted all participants. While we are bookending the discussion with our cameras on, we will be turning them off during the session to maximize the slide size on your screens. During the presentations, we encourage you to submit questions by typing them into the questions page on your control panel on your screen. We will answer some questions during the program and in a Q&A session at the end of the program as time permits. In the event we are unable to answer your question during the live webinar, your local engineered wood specialist will follow up with you at a later date. A recording of today's program will be posted on our website, www.apawood.org, in about a week. Our class today is approved for both AIA and ICC continuing education credits, and the certificate will be provided for all attendees to use for AIA, ICC, or other organizations that self-report continuing education credits. Your feedback is important to us. We would like to point out that you see a QR code on the screen. If you open your camera on your smartphone and point it at your screen, a link will pop up to take you to the survey on this session. We will show you this link a few more times throughout the course today. For live attendees, the link will also be included in the email you receive about an hour after we conclude. For those of you just joining us, welcome to our webinar titled Wood Structural Panels as an Air Barrier. Our presenter today is Stephanie Thomas-Reese, Engineered Wood Specialist for APA based in Florida. From her location in Central Florida, she consults with builders, designers, and code officials on using engineered wood products efficiently and cost effectively. Stephanie is an experienced designer and energy professional with a BS degree in architectural design from Clemson University and a Master's of Science degree in energy efficient building from Oxford Brookes University. As a building science professional, Stephanie's past roles include project architect, energy efficiency director, code coordinator, and adjunct professor teaching sustainability, construction materials, and methods. Stephanie is a competitive water skier, loves running marathons, and enjoys offshore fishing. For those of you just joining us, welcome to APA's webinar on the topic of wood structural panels as an air barrier. I will now turn the microphone over to our speaker, Stephanie Thomas-Reese.
Thank you, Bob. Good to have you all here. Thanks for joining us. So we're just going to get started, and I am going to close my camera, I believe, so that you guys will have the full screen. All right, so let's get started. This slide's going to outline what we'll be going over in this seminar. We're going to discuss the importance of air barriers and air barrier systems and how using wood structural panels optimizes the air sealing function of a barrier system quite well. Now, there's different types of these systems and strategies, so we're going to highlight what qualifies those systems as an air barrier and recognizing those challenges that might occur. I'll go through the code requirements for air barriers and how and what kind of testing is recommended if not required by the code. And then we're going to show some examples in the field, properly and improperly installed air barrier systems. And so we'll walk through some basic principles. We'll define the air barrier. We'll touch on other barriers of the building enclosure and what they control. I'll also go through, like I said, the energy code and those other voluntary certification requirements where testing quantifies the compliance of an air barrier. I'm going to explain the different types of air barriers, their limitations, and where they can be installed, which will include some pictures of both good and bad examples. I'll go through a series of checklists that address the code requirements and best practices. And then lastly, we'll finish up with some different assemblies and their advantages. So, defining the air barrier. The 2021 International Energy Conservation Code defines an air barrier as a material or materials assembled joined together to provide a barrier to air leakage through the building envelope. So That means it can be a single material or combination of materials, and its intent is to restrict unintentional flow of air through a building envelope. Now, a whole building air barrier includes all 6 sides of the envelope. So if you look at this cross section, which is of my own home, you should be able to start at one point and follow the air barrier around the entire perimeter of the house without lifting your pen. So this is a good way to determine if the air barrier system is continuous. And so an air barrier may be, like I said, a single material or a combination of materials or an assembly. And the components can be rigid, like OSB, plywood, rim board, etc. But an essential part of the air barrier performance is that an air barrier material has a low air permeance, which is the amount of air that migrates through that material. Now, the accepted level of air permeance of materials defined in many codes and standards around the country is less than 0.004 cubic feet per minute per feet square. Now, using test method ASTM E2178, that's the standard test method for air permeance of building materials. So this test method is not a specification, but it defines the maximum allowable air permeance for material that can be used as part of the air barrier system. It does not address the installed leakage performance of the building materials. And this value is also the threshold used by the Air Barrier Association of America in their evaluation of air barrier materials. And this group has taken a lead position in developing and promulgating standards. Now, APA, we have some publications, and you'll see one noted here at the bottom of this slide. This particular one shows the measured air permeance for data for wood structural panels, and it also shows the results of that threshold for an air barrier material, and that is available on our website that you can download that for free. So as I mentioned on the previous slide, plywood and OSB products with a permeance category or a thickness of 3/8 or greater are recognized as air barrier materials by ASHRAE, which is the American Society of Heating, Refrigeration, and Air Conditioning Engineers, the International Residential Code, the International Energy Conservation Code, and the National Building Code of Canada, for any of you out in Canada. So I mentioned our publication with the tested air permeance. There's just a copy of that here. And this publication has the detailed information about testing, and it discusses the performance of wood structural panels when used as part of an air barrier system. So air barrier system components, they can also be flexible, but they must be installed per manufacturer specifications. And they usually have an ICCES report for air barrier use. Now, these are materials like your wraps, Tyvek, Typar, asphalt paper, and products tested per their respective standard. And there's a couple of them listed here: ASTM E2357, E1677, or E283, which is the one for windows, curtain walls, and doors. Now, sealants are also part of the air barrier system, and as components, they're always flexible. Construction adhesives and glues are commonly used by trades as a means of sealing, sometimes overused, and they have a good holding power, but they do not flex as those materials move, which can encourage air leakage. There's not a one-size-fits-all on air sealing, and there's different components that need to be specified for those specific uses and locations with an air barrier system. And those construction adhesives and sealants, they must be labeled as ICC ANSI for an approved sealant to be used. So an air barrier are the components or the system of components that create that barrier against air leakage of an enclosure. But a properly enclosed building has other control layers that manage not only the transmission of air, but they control water, heat, and even sound. And these are those control layers we'll look through. So in this picture, you can see an example of back in the prairie days before we had electricity or industrialization. the goal was really shelter, privacy, if possible, without interior walls, and security. And so one layer accomplished everything. So that pretty much shows it's controlling everything, where not much difference is between your ambient and under roof conditions. And just in the past, say 40 years, there's been major improvements in HVAC equipment, as well as a better understanding of building science through research and monitoring homes to study how people live in them and how lifestyle affects the performance of these systems. Now, with that knowledge, we've been able to optimize the function of those layers with respect to climates so that the enclosure is climatically responsive. Now, there's a lot of control layers in a building, and this seminar will focus really on the air barrier, specifically using wood structural panels as an air barrier. But again, we want to understand those different layers and the proper installation of them to make that system work effectively. And so there's 4 main environmental control layers in a building. We have air, vapor, water, and the thermal barriers. And we'll go through them, make sure we understand the purpose of each of them. So the building enclosure is basically what keeps the outside and inside separated. And the air barrier and those other control layer materials incorporate into an assembly to create that enclosure. And then how that enclosure performs or fails is simplest and necessary once we clarify those control layers. So each barrier or layer has a different function which affects the performance of the entire building enclosure. And we use different materials in houses to achieve those various levels of control that we need. And what any one house needs depends on the climate and what its occupants do when they're inside, or what I like to call their lifestyle. It's different for everyone. And so we define the air barrier in terms of a material and a system, but let's think about it as it relates to those other control layers. So it's any material, combination of material, prevents air from moving unintentionally in and out of the building enclosure due to those differential air pressures. And so these air control layers include house wrap, the wood structural panels, your windows, your doors, weather stripping, and so on. And so those things help with heating and cooling costs. They improve your indoor air quality. You basically help isolate that indoor environment and ultimately results in a durable building. And the air barrier is also a key component to prevent moisture issues as well. So air barriers and vapor retarders are commonly confused though. So I'm going to talk about vapor retarders for a minute. And remember, air barrier performance is a material with a low air permeance. That's the amount of air that migrates through it. Vapor barriers or retarders are used to slow down the movement of water vapor through a roof, wall, and floor assemblies. Now, the older term vapor barrier is still used, but vapor diffusion retarder is a little more accurate. And originally, vapor barriers were used to prevent wall and ceiling assemblies from getting wet during the construction process, but they also could trap moisture, which could enhance or cause rot and mold to occur. And the moisture in a system automatically moves from an area of high concentration to an area of low concentration. And this is ultimately what a vapor barrier is designed to prevent. And types of vapor retarders are polyethylene plastics, plastic-based polyisourinate foams, even medium density closed cell foams, like you see in this example on the slide. They should be installed on the warm side of the insulation in a building assembly as determined by climatic conditions. So in warm climates, it'll be on the exterior, cold climates, it'll be on the interior. Now, it's important to note that it does not control airflow. Therefore, the vapor barrier does not have to be continuous. It doesn't have to be free of holes, doesn't have to be lapped, does not have to be sealed, etc. So a hole, for example, in a vapor barrier just simply means that there'll be more vapor diffusion in that area compared to other areas of the vapor barrier. And so the ability of a material to retard the diffusion of water vapors measured in units known as perms or permeability. And the International Residential Code describes basically three classes of water vapor retarders. The lower permeability, the less water vapor a vapor diffusion retarder allows through that material. Now, this perm rating is defined by standard ASTM E96, and vapor retarders materials basically fall into those three classes. Class 1 here, materials that have a perm of less than 0.1. Again, those include sheet polyethylenes, non-perforated foils, and even glass. Class 2 materials, they have a perm rating between 0.1 and 1, and those might include craft paper or extruded polystyrene. And then your class 3 vapor retarders have a perm rating between 1 and 10. This includes latex paints, maybe a 30-pound felt, and wood structural panels. So again, a couple of things to note, that the permeance of a material is inversely proportional to its thickness. So 2 layers of a material will have half the permeance of a single layer. And also, vapor permeability is sensitive to relative humidity. So in other words, at say 50% RH, vapor permeance of a 7/16 OSB sheathing is about 2 perms, but may be increased to 12 when the RH is at 85%. So you can, more about this is described in that publication that you see here on this slide, and again, available on our website. But for the purposes of this seminar, both 15/32 and plywood and 7/16 OSB are regarded as semi-permeable or class 3 materials in the code. It's important to recognize when to use retarders, either class 1, 2, or 3, which varies by the climate zone. It's easy to understand that in some climates, the higher moisture concentration will be inside the house, and in others, it might be on the outside. But what does this mean from a practical standpoint? So in Chicago, which is climate zone 5, where plywood or OSB exterior sheathing is used, an unfaced fiberglass bat can be installed within the wall cavity, and painted gypsum board with the latex paint, a class 3 vapor retarder, is required on the interior of this assembly. Now, this assembly that I just described is moved to, say, Minneapolis, which is climate zone 6, a class 2 vapor retarder is required on the interior. That might be craft paper, faced fiberglass bat. So just a couple different scenarios where the climate is really important. Now, the next control layer that I'll brief here is, it's pretty easy to understand. Trying to keep rain, including horizontal rain like we get here in Florida, when wind drives it into our buildings, when we don't want that inside. So that water barrier is designed to keep water from seeping into the building enclosure. We hear about drainage planes all the time, and this ensures that if and when water does penetrate that primary water barrier like the cladding, it has a way to drain and escape from behind the cladding, meaning it doesn't get trapped. And this helps our structure stay or be more durable and dry out. And finally, we have that thermal control layer. This prevents heat from moving through the building envelope. And it comes in a few forms. The easiest to understand is insulation. There are also thermal barriers that manage the loss or gain of heat by radiation, such as a radiant barrier. Now, this is a photo of a radiant barrier roof sheathing, which mitigates heat gain in attics, frequently used throughout the South and Southwest US. So always best to refer to the manufacturer's information, though, for proper installation of a radiant barrier. Now, those 4 main environmental control measures I briefed us on, air, vapor, water, and thermal. I'm just going to recap here that the building enclosure keeps outside and inside separated, and the air barrier and those other control layer materials are incorporated in an assembly to create that enclosure. Now, to understand how the enclosure performs or doesn't, it's necessary to clarify those control layers and their function that affects the performance of the entire building. We use different materials in houses to achieve those various levels of control that we need. And again, what any one house needs depends on the climate. And again, that occupant's lifestyle perhaps should be considered too. So these components can be part of multiple layers. For example, wood structural panels with a radiant barrier, like I showed in the slide before, used on the roof. And that can be part of that air vapor thermal control layer. Just like weather stripping is part of the air part of a water control layer. Now, how the code or the International Energy Conservation Code defines air barriers is important because it also sets the criteria on how it's measured and the allowable air leakage for it to be code compliant. So I'll go through these requirements and also some voluntary certifications where testing quantifies compliance. Now, there's 4 methods for compliance with energy codes, and we're not going to go into detail on them in this seminar. We have a recorded seminar on our website available, which I'll show you a snapshot of that in the next slide. But what's important to note is that no matter what compliance path you choose, air sealing and testing to ensure air leakage is in compliance is mandatory. This is that snapshot that shows, if you're interested in that other webinar that we had, I just wanted to show that so that this is one that looks more at meeting the code using the performance pathway. Now, using the performance or the energy rating index path, we refer to this guide and see the maximum is 5 air changes in all climate zones. So if we're using the prescriptive path, the maximum leakage rate for climate zone 0 to 2, and is 2, and the maximum is 3 air changes for climate zones 3 to 8. Now, ASHRAE's further reassigned counties to climate zones based on new climatic data. The air tightness of a building is measured in ACH, like I mentioned, air changes per hour, and it's determined by a blower door test where the building is depressurized by a fan in the door, like you see in the left picture, and it basically creates a pressure difference at 50 pascals. Now, the number of times that the entire volume of the air in the house exchanges with outside air is measured. These pictures demonstrate that blower door equipment. The door has an insert with a fan, and the right-hand picture shows the quantity of air changes, and in this instance, we see 5.0. So for a home in all climate zones to be in compliance with the 2021 Energy Conservation Code, the air in your house would exchange with outside air no more than 5 times with a pressure differential of 50 pascals. In addition to the air leakage test or the whole house pressure test, field verifications required on a number of items. So in table 402.4.1.1 of the code, it states that thermal envelope components must be installed per manufacturer's requirements and inspected. So we're going to dig into this a little bit. But first, let's talk about, again, the main principles of an air barrier and look at some of the different types. So there's different types of those assemblies. Some have limitations as to where they can be installed. So knowing those limitations allow you to choose the right barrier assembly for the project and where it can be installed. So mentioned the first thing, ensuring that you have an air barrier, is continuous. Continuously sheathing your walls with wood structural panels is a good start. And not only has air barrier advantages, but the walls continuously sheathed in plywood or OSB also provide an excellent nail base for brick ties, siding, and trim. Wood structural panels within the assembly are strong and stiff, which is another important principle of an air barrier. And wood structural panels can resist shear forces and uplift during high wind events, and can also reduce the chances of flying debris, not only compromising the air barrier, but the integrity of the structural system. This picture shows just how during a high wind event, debris can penetrate components of an air barrier, like the foam insulation. It's not as strong and stiff like a wood structural panel. And once breached, the entire system is weakened and not only allows water into the home, but could cause a pressure differential that could lead to a complete roof removal. Now, air barriers should be durable, and wood structural panels are able to withstand a lot more construction mistakes than, say, less durable materials, but it can sometimes happen. We just need to make sure that they are repaired. And finally, they need to be air permeable. So wood structural panels meet all the requirements of an air barrier. Of course, they do have seams and need to be protected from the weather, but the seams typically fall on those supports, as you can see from the photo on the left. And there's a few options to add to wood structural panels to complete your air barrier assembly. Now, the air barrier assembly will likely include both flexible and rigid materials, and we've talked about using rigid wood structural panels for that part, but options for flexible air barrier assemblies might include polystyrene foam boards. Air barrier assemblies consist of different materials. Here's a good example of rigid air barrier assembly using wood structural panels. Plywood and OSB can effectively be used as an air barrier assembly in roof and wall applications. And flexible air barriers can be effective, but the rigid has added benefit to protection against projectiles during a storm, like in the slide I showed earlier, where flying debris can penetrate that exterior finish and go through those flexible sheathings. The mechanically attached air barriers are those like water-resistive barriers that are fastened with nails or staples to the solid substrate that makes the air barrier water resistant. Now, these should be installed per manufacturer's recommendations and installed in a way that they don't flap in the wind, because flapping tends to deteriorate the membrane and provides opportunities for unexpected holes and tears. So here's a not so good example of an installation or repair where it's just not consistent. There's also self-adhered membranes, which are flashings or tapes that can be stuck to the substrate or around openings in a substrate. And so careful attention to the types of adhesives, making sure they don't lose their adhesion under the conditions that they may be exposed to, is important. So in this picture, this is being used to provide an air barrier continuity from the foundation to the exterior wall. A laminate roller is used here to apply pressure to the membrane to facilitate adhesion to the substrate and eliminate air pockets and pinhole leaks. Now, by carefully selecting the right tape when two different substrates intersect is key too. There are some systems that are called fluid applied air barriers, and they can be sprayed, painted, or rolled on, as you see in this example. And they can serve as the primary air barrier and water resistive barrier for the wall system, and in some cases as the vapor retarder, depending on the vapor permeance of the membrane. Now, the type and how it is installed is essential, given that the single material may be intended for 3 different functions. This fluid applied air barrier is expanding, and it's critical that the designer be fully informed, because not all fluid applied air barriers properties are equal. And just because certain requisite tests are performed does not make it equivalent in regard to long-term durability against crack bridging and elongation. And finally, some manufacturers provide wood structural panels with integrative water resistive barriers that provide a combined air and water barrier. The seams still require taping, and holes also still need to be repaired. All right, I mentioned the checklist earlier. We're going to look at air sealing methods that ensure complete air barrier protection and the checklist required by code and other third-party certifications that require completed air sealing. And so just because we can use wood structural panel sheathing as an air barrier doesn't mean we get to ignore the details. So very important to make sure the system includes sealing of all the areas that may have leakage. Now, this could include intentional and/or accidental holes. The smaller the hole, the greater the pressure needed to drive air through it. So focusing on the larger holes first, like your windows, doors, garage openings, will obviously have the biggest impact. Windows and doors, due to the quantities and how large these windows are getting these days, they can have the largest leakage, and proper detailing is important to ensuring that system performs well. And not only the detailing, but just making sure the steps are implemented in the field correctly. So where air moves, so does heat and moisture. And this is especially true at the structural penetrations, like where the garages and the balconies are integrated, or any area between that conditioned and unconditioned space that has pressure differences that can cause that uncontrolled air movement. Now, these common pathways for leakage are found in both single family and multifamily housing units. And as much as 30% of a home's energy usage can be from air leakage. So we have some publications. APA's Build a Better Wall publication is referenced again at the bottom of this slide, and has some great step-by-step window and flashing details. But let's step back to that air sealing checklist from the International Energy Conservation Code. It's again designed to ensure that the building passes the blower door test. So it's important to know that the table exists to make sure that it's being used during design, construction, and installation. Now, this is just a partial snapshot, but I'm going to go through some of the items individually with some images and examples. But you can find this in the table in its entirety in the code chapter 4. The first line item we covered, continuous air barriers shall be installed in the building envelope, and breaks or joints shall be sealed. So most builders accomplish this by taping the seams of the water-resistant barrier over the wood structural panels. And proper shingling and sealing of that air barrier is key to resisting air movement and preventing moisture intrusion. So this photo on the left shows a properly installed air barrier with, say, 6 to 12 inches of overlap that's noticeable, and the taped edges. APA's Build a Better Home Wall publication provides specific instructions on how to do this effectively. And this is that same publication, has the window flashing details I showed in the previous slide. But unfortunately, we do see a lot of examples of poorly installed air barriers. And here's some images that have arrows that identify those gaps, loose edges, unwrapped corners, and unlapped and improperly taped seams that would not be considered an effective air barrier. So both these scenarios could allow air leakage into the insulated wall system. The next, fully separating the attic and unconditioned ceiling space from the conditioned part of the home, very important. At knee walls, ceilings, utility soffits, those can cause significant air leakage if they're not fully isolated from that outside air. And maintaining that continuous air barrier between those soffits and that conditioned space is key to a homeowner's comfort, which also contributes to energy efficiency. And breaks in the air and thermal barriers for those soffits enables those hot and cold spots in the home and typically lead to complaints. So this picture on the left is of OSB being used as the air barrier material between the utility soffit and the attic space, and the picture on the right is of the drywall being used as the air barrier between the utility chase and the garage ceiling. Now, either of these options work, and properly separate that conditioned and unconditioned space. But both these soffit pictures are missing the air barrier between the soffit and the ceiling system above. The drywall installer may have to come back and place drywall at the bottom of that I-joist if a gap was left to even slide the drywall in. Now, gaps like these will make it challenging to meet the blower door test requirements and hard to fix by the time you get to that point. So very important to catch them during construction. Another air barrier that's often missed is the knee wall at the attic separation. Once the batt insulation is installed and drywalled, the insulation will have 6 sides of containment and be fully encapsulated, assuring energy performance. Now, this image shows studs on each side, top, bottom plate, and OSB used as the attic side air barrier. This application is appropriate for single family or air barrier in attics of multifamily units that are not on a common wall. Say if the unit had like a vaulted ceiling that's not adjacent to the common wall. But in multifamily housing, there may be fire code requirements that mandate this barrier be rated for 1 to 2 hours. And in that case, a fire rated assembly may be substituted here. Next in that checklist, other than penetrations in the thermal envelope, one of the biggest sources of air leakage is the junction of the sill plate and the foundation and the rim joist junction. So sealing these areas is very important because you often have material changes. In addition, all cavities and corners need to be insulated with a material having an R value of 3 per inch minimum. Fiberglass, for example, has a minimum R value of about 3.2 per inch and can go as high as 4.2 depending on the product and density. Foams vary greatly from R4 to say R8.6 per inch, again, depending on the type, material, and density. So it's important to know that there is an exception to this requirement when solid wood is a structural necessity. So the photo on the left demonstrates a foam sill sealer, and on the right shows the wall with the foam sill sealer and a caulk bead seal. Now, foam sill sealers are most common, but there are many products and applications that can be used, including caulk. So if you're going to go through that extra cost and labor to put a bead down, make sure it's installed properly and it's the right material. So in this picture, you see a bead of caulk, hasn't been laid straight, not continuous, possibly the wrong type in that it didn't make a good seal. So, and it's also subject to damage if it's installed at the time that the sill plate's installed. But again, if it's left right up until drywall, it could get missed entirely. Now, the picture on the left demonstrates air sealing using caulk and foam from the attic side. The photo on the right demonstrates that sealing after those penetrations were made at the top plate. And this method is often the most common and most cost-effective and easiest for builders. When penetrations in the walls are complicated, sometimes windows, doors, and skylights, they have a lot of areas that require that special attention. And this has one of the largest returns for the investment because window and openings are large areas where leakage can occur. And there's usually many of them in homes. So while fiberglass has traditionally been used, it doesn't stop air movement. And note, low expansion foam provides a better seal and doesn't affect the jam performance, but we want to make sure it's low expansion. Here's a photo on the left that demonstrates properly sealed window using that low expansion foam. And on the right, fiberglass insulation's been used, and as I mentioned, it's not a good air barrier. Maybe a good insulator, but it does not stop that air movement, and it's not permitted around windows and doors. A rim joist air sealing is similar to that sill plate sealing. It can be a large area for air leaks and needs proper air sealing and air barriers. The area of most importance is between that sill plate and the rim board, as one is often laid flat and one stands on the end, and gaps and cracks often occur from that warping and uneven foundation walls. Now, on the left, you can see spray foam used, and in this application, that foam acts as both the air seal and an insulator. And this is probably one of the most cost-effective uses of spray foam in the home. And on the right, you see some face fiberglass insulation used with caulk air sealing. Both are effective and meet the requirements of the code. Now here's an area where you have a jog in the wall, multiple materials coming together at the rim board. So this area is especially important to seal, and even caulking can be very cost effective at the seal plate here. But one of the largest comfort complaints builders receive are those rooms over the garages and cantilevers. And this is where homeowners notice the floors and spaces being hot or cold. These complaints could have been prevented by properly air sealing and aligning of those air barriers. So isolating the floor system with air barriers are often challenging for contractors and likely different from the way they handled these in the past. Plumbing, wiring, and HVAC ducts should be sealed around as they pass through those air barriers. So here on the left, the floor system is insulated with a blown fiberglass application, and the ends are properly sealed. And then when the ceilings drywall, the system will be fully isolated and energy efficient. On the right, there's a non-compliant application, poorly installed fiberglass bats with gaps and spaces that will likely result in homeowner complaints and discomfort. Now, crawl spaces are covered in both the IRC and the Energy Code, and can either be conditioned with insulated walls or unconditioned with insulated floors above. So if the crawl space is unvented and an exposed earth is present, the space must be covered with a Class 1 vapor retarder and the joints taped. So care should be taken so that these retarders are not damaged from construction workers walking on it during construction. Here the left picture shows a vented crawl space with an insulated and sealed floor, and the image on the right shows an unvented conditioned crawl space with those insulated walls. Now this is critical area, and not just for air leakage purposes, but for indoor air quality. So the garage separation, air sealing needs to ensure proper barrier between the garage and that conditioned space. If there's leaks, when the HVAC system's energized, it can pull uncontrolled air from the garage into that interior space, and this can be harmful pollutants that are kept in the garage, like your gas cans and pesticides and chemicals. And another critical area that has large penalty if it's not installed and sealed properly is at the exterior walls adjacent to those showers and tubs. And best executed if completed by the framer prior to those tub and shower installation. Here we have a photo on the left that shows that wood structural panel used behind a prefabricated shower insert, and the right image shows flexible sheathing used behind the shower enclosure. If it's not done by the framer before the tub and shower are roughed in, it could get missed and forgotten, and it's very hard to accomplish this correctly once those showers and tubs are in place. Duct shafts and utility penetrations, whether they're between the floors or through the thermal envelope, need to be sealed, and we're going to go through a number of these fairly quickly, and our list won't be comprehensive. Many builders have a rule with contractors that any hole they make, they must also seal. And this prevents subcontractors from cutting oversized or misshapen holes in the building envelope. Here's a few examples of properly sealed air barriers at the HVAC penetrations, and this can be done with mastic as well. Plumbing and wiring penetrations are another area that require attention. And Another type of penetration that needs those to be sealed are those electrical boxes. A simple step makes a big impact because there's many boxes typically that are installed in homes. And of course, any HVAC registers that penetrate the thermal envelope need to be sealed properly too. So it might seem like a lot of work for small monetary savings, but there's no incremental cost associated with improving the air leakage when it comes to just doing it more carefully. Now this chart shows the impact of using the 3 air change per hour rate as a baseline with respect to yearly energy costs. So going from 3 air changes to 4 air changes is a cost difference of about $28 a year. While it's not a lot, to put it in perspective, in climate zone 3, the yearly energy cost difference between an R20 exterior wall and an R13 exterior wall is only $27 yearly. So this is about the same as the energy cost of air leakage between 1 air change. So in other words, it costs the consumer the same in energy as if they only had an R13 versus an R20 wall, just the energy cost alone, not to mention the incremental cost of the materials for an R20 wall. So there really should be no cost associated with improving that air leakage, just taking a little bit better care to do it properly and as tight as possible. As some builders picture frame each wall cavity with an air sealer, and while this does reduce air leakage, in most cases it's not required for code compliance, and it can have some incremental costs associated with them. All right, so with structural panels, they have advantages over other air barrier alternatives, and so we're just going to touch a few more slides that will show some examples of this. Here, using wood structural panels as part of your enclosure can provide continuous, uninterrupted air barrier assembly in addition to a more consistent structural system. They provide solid and stiff backing for house wrap, which prevents accidental holes and gaps when protecting openings, but again, got to be flashed entirely and effectively. And because air is going to try to move in and out of a building, if you don't have a rigid air barrier system, then that system can end up looking something like this from just the pressure differentials. So the strength and stiffness of wood structural wall panels help avoid this pumping effect that's common in flexible exterior air barrier membranes. Another common error when assembling those barriers is the improper or no overlap. So here you see it's just barely maybe 2 inches of overlap at the seam. The photo on the right shows tape that is sealing that transition between masonry and wood frame at the top of the CMU wall, which may be the right tape. However, they stopped it just short at that red arrow. And here, while the image to the left shows good air sealing technique of the air barrier system from a pipe penetration, it fails to address the stress tears from the wrap being stapled without caps. So long exposure to the sun can start to degrade this, making it more susceptible to tears. Now here you see an unintended hole in a flexible wall sheathing that will need to be fixed to meet the air sealing requirements. And of course, it's not impossible to have holes in wood structural panels from mishaps, but it is less likely. So again, make sure we do address those instances too. And here we have some intentional holes in a panelized or a cartridge bore system that's necessary for installing with a crane, but they were repaired with a plug and blocking. So this is over a garage where proper air sealing is necessary, especially when that space is an interior conditioned space. So with that, we've showed some advantages to using wood structural panels as an air barrier. There's other benefits, and I'll brief you with some additional advantages before we wrap up here. Wood structural panels are strong, resilient, they're solid substrate for siding and trim, they're economical, they're a sustainable building material. There are insulation options that are effective, and when using advanced framing methods, They can also provide wall bracing methods too. So we have a lot of information and tools on our website to help you understand each of these benefits. And back to the publications that we have for air sealing. We also have a number of different tools I mentioned throughout this presentation. So those publications are exemplified here, and you can download them from our website at www.apawood.org. And with that, thank you for your attention. My contact information is here, along with our help desk email and our website again. And don't forget, complete the survey. I placed the QR code here again, so you can use your smartphone to read that and take the survey going to that link directly. That link will also have all of our field service reps available throughout the US, so you can find one that's closest to you in case you want to reach out to them. And I am going to hand the audio back to Bob in case there's some questions that we might have time for.
Thank you, Stephanie. Hopefully everybody found that presentation helpful. We do have a couple questions that came in. I'd like to see if you can have the opportunity to ask them. The first question, as wood structural panels becomes moist, does it decrease the sheathing's ability to act as an air barrier?
So we get this question all the time about exposure to the elements and wood structural panels, but it's essentially the same answer. It does not impact the air permeability of the wood structural panels, but I want to further clarify that A, they shouldn't be exposed. We should try to protect them as quickly as we can, and they should retain their structural integrity, providing that they can dry without being damaged. So same goes for air permeability, as long as that they're not damaged, while they're wet, there's not a hole that penetrates them, as long as they're allowed to dry, and you don't have significant edge raising that could cause some of those seams or some of those joints between the wood structural panels to further gap, then they should serve perfectly well as an air barrier.
Okay, thank you. When wood structural panel seams fall on the stud, is that still considered an air impermeable condition? I've heard that it could be as much as 0.8 CFMs per square foot at 75 pascals. Can you discuss that?
So yeah, so when those seams do fall on the studs, there could be some leakage. It's usually very negligible, but it's going to be the same for, say, any material that has a seam, whether it has a weather integrated barrier to it, that is still going to fall on that stud. So anywhere you have that material difference at that marriage line, it does need to address to make it more resistant to air. But again, it's still code compliant and it's negligible. It may not pass maybe some higher voluntary certifications that home may be after, say for a passive house or something like that, but it does meet minimum code. And again, just addressing any of those expanded leakages or seams that might have greater than normal gaps in them.
Okay, thank you. In an unvented crawl space with ground and wood structures exposed, how would you treat the crawl space?
So I think I mentioned that in one of the slides. In an unvented crawl space, you would treat that with a class 1, so like a 6 mil poly sheet that's taped in the seams. And then if it's a vented, well, again, that has to be both horizontally and vertically fastened all the way from the floor to the wall. So again, has to be additional 24 inches insulated and per that climatic zone that the structure or the home is located in.
Okay. Well, thank you, Stephanie. That's all we have for now. And with that, I'd like to thank everybody for their attention. For this webinar, I'd like to make sure that everybody is signed up to receive our APA update newsletter. So you will be notified of future webinars and updates to APA publications and standards. To receive it, all you need to do from our home page is to click on Sign in the upper right-hand corner of the page. In the drop-down menu, simply select Register. Then you will need to let us know what you'd like to receive from APA, in this case, the APA Update newsletter. I'd like to mention that APA has field staff located throughout the country. These talented people are available to assist design professionals, builders, and code officials. Their individual contact information can be found on our APA website, www.apawood.org. Please reach out and take advantage of this free resource. Don't forget to download the AIA or ICC certificate of completion. And with that, I'd like to thank you for attending. Have a great day.